When we think of modern science, many of us imagine laboratories in Europe, and names like Newton, Galileo, or Einstein. But the story of science does not begin there. To truly understand how modern science was born, we must travel back more than 1,000 years to the cities of the medieval Islamic world. At a time when much of Europe was facing political instability, the Islamic civilization was experiencing an extraordinary intellectual awakening. In cities like Baghdad, Cordoba, Cairo, Damascus, and Sumer, knowledge was not only preserved, it was questioned, tested, expanded, and transformed. This period is known today as the Islamic Golden Age, and it laid crucial foundations for modern science. This scientific rise did not happen by accident. From its earliest days, Islam emphasized learning and reflection. The Quran repeatedly invites people to observe nature, to think deeply, and to seek understanding. The very first revealed word was read. Knowledge was seen as a moral duty. Scholars were supported by rulers and institutions, and learning was open to Muslims, Christians, Jews, and others alike. This created a culture where curiosity thrived, and where science could grow beyond religious study. In the 9th century, this spirit took physical form in one of the most important institutions in history, the House of Wisdom in Baghdad. It was far more than a library. It was a translation center, a research institute, and a meeting place for the world's brightest minds. Works from Greek, Persian, Indian, and Chinese civilizations were translated into Arabic. But Islamic scholars did not stop at translation. They questioned ancient authorities, tested ideas against observation, and corrected errors through mathematics and experiment. This shift from accepting tradition to verifying knowledge through evidence was a turning point in the history of science. One scholar, in particular, embodied this transformation, Ibn al-Haytham. Studying light and vision, he rejected speculation and insisted on proof. He formed hypotheses, designed experiments, controlled conditions, and recorded results. Centuries before the European scientific revolution, Ibn al-Haytham was practicing what we now recognize as the scientific method. Modern science would later adopt this approach, but its roots were already firmly planted in the medieval Islamic world. Science needs a language, and that language is mathematics. During this era, scholars like Al-Khwarizmi developed algebra, a word derived from the Arabic al-jabr. He also formalized step-by-step problem-solving, what we now call algorithms, a term that comes from his name. Without algebra and algorithms, there would be no physics equations, no engineering models, and no modern computing. In medicine, Islamic scholars transformed healing from tradition into evidence-based practice. Ibn Sina, known in Europe as Avicenna, wrote the Canon of Medicine, a medical encyclopedia that remained authoritative in European universities for over 6 centuries. Hospitals in the Islamic world used patient records, clinical observation, and ethical standards that resemble modern healthcare. Medicine became a science, not a collection of myths. Astronomy flourished as well. Muslim astronomers built observatories, developed precise instruments, and refined planetary models. They improved star catalogues, calculated planetary motion with accuracy, and corrected flaws in earlier Greek astronomy. Many star names we still use today, such as Aldebaran and Betelgeuse, are Arabic in origin, but their most important contribution was not naming the stars, it was rethinking how the universe works. In the 13th century, at the Maraga Observatory in Persia, a scholar named Nasir al-Din al-Tusi introduced a revolutionary idea. He developed what is now called the Tusi couple, a mathematical model showing how straight-line motion could be produced from 2 circular motions. This solved major problems in planetary models inherited from ancient Greece. It was elegant, precise, and mathematically powerful. 2 centuries later, in Renaissance Europe, Nicolaus Copernicus proposed his heliocentric model, placing the Sun, not the Earth, at the center. His work is often presented as a dramatic break from the past, but historians noticed something striking. In De Revolutionibus Orbium Coelestium, Copernicus used geometric constructions that are mathematically identical to the Tusi couple. The diagrams, the motion, the logic, they follow the same principles. Copernicus did not name Altazzi, but the resemblance is undeniable. This was not coincidence. It was transmission. Knowledge crossing civilizations. By Copernicus's time, Islamic scientific works had already reached Europe through translation centers in Spain and Italy. European scholars studied Arabic astronomy, mathematics, and medicine as advanced science, not ancient history. Copernicus did not start from nothing. He inherited centuries of Islamic scholarship that refined the mathematics of the heavens. In chemistry, scholars like Jabir ibn Hayyan developed experimental techniques, laboratory tools, and chemical processes such as distillation and crystallization. In engineering, Muslim inventors created water pumps, mechanical clocks, and automated machines, early examples of applied science. These innovations were not theoretical luxuries, they solved real problems in agriculture, medicine, and daily life. So, how did this knowledge shape modern science? Through translation and contact. As Europe emerged from the Middle Ages, Latin scholars translated Arabic scientific works into European languages. Universities in Spain, Italy, and France used Islamic textbooks as foundational material. Figures of the European Renaissance did not start from zero. They stood on the shoulders of Islamic scholars.